Okay, so we are still in radians, okay, and we're still factoring it. And how I know I can factor this equation, so we've got 2 sine squared of x minus sine minus 1. Since I have different degrees of the sine function, that's how I know I would factor. Okay. And again, if you want to think of sine as something different, like this would be sine squared, so let's say I'm going to call sine A. This would be like 2a squared minus a minus 1, you can see that's a trinomial you can factor. So if you would prefer to factor just using a different variable instead of the trig function, factor that way, and then put the sign back in. Okay. So to factor this, to multiply to 2 sine squared, I'm going to have sine of x and 2 sine of x. Okay. To multiply to negative 1, I'll have a minus 1 and a plus 1. And then I'm going to have to check that these are the right factors. So if I multiply the outside, 2 sine times negative 1 is going to be negative 2 sine. The inside will be positive 1 sine. So negative 2 sine of x plus 1 sine of x, that does add up to negative sine of x. So I know that I have the right factors. Okay. Then I'm going to set each one equal to 0. Okay, so to solve this equation, I'm going to subtract the 1, divide by 2. Okay, and then on the second equation for sine of x minus 1, I'm just going to move the 1 over. Okay, and then I'm going to solve both of these equations. I don't have to worry about extraneous solutions on this one for 2 reasons. Okay, sine is never undefined. Okay, so that's one reason. I know these will never be undefined. And also this equation only has one trig function. It's just sines. You only have to worry about the extraneous solutions if you get quadrantal answers and you have like a tangent and a cosecant like we did on that first one. Okay, so this sine ratio, this is opposite over hypotenuse. So this does match the side lengths of a special right triangle. Okay, so sine's going to be negative on the bottom, where the opposite is negative. Okay. So this side will be root 3. And so that will make my reference angle, I'm still in radians, so across from the 1, that's pi over 6. Okay. So from this first equation, in quadrant 3, I'm going to do pi plus my reference angle. So pi plus pi over 6 is 7 pi over 6. And then in quadrant 4, I'm going to do 2 pi minus my reference angle. So that'll be 11 pi over 6. Then for the second equation, this is my opposite over hypotenuse. So this would be 1 over 1. So this is definitely not a special right triangle because we don't have a hypotenuse of 1. Okay, so remember, when the opposite and the hypotenuse are the same, that makes it quadrantal. Okay. So the hypotenuse is always 1 for quadrantal. Opposite goes with y. So I'm looking for where y is positive 1 in this equation, which would be at the top of the y-axis. Okay. So that angle right there is just going to be pi over 2. Okay. And even though it's quadrantal, I don't have to worry about it being extraneous because I only have sines in this equation. So let's go ahead and look at another one. We'll do one of the reciprocal functions, secant. So we have 3 secant squared minus secant of x minus 4. Okay, so I'm going to factor this. So we'll have 3 secant of x and secant of x. That'll multiply to 3 secant squared. Then what multiplies to negative 4, you could try negative 2 and positive 2. When I check that though, that's going to give me positive 6 minus 2. Okay, that's going to add up to 4 and I want negative 1. So you could try switching the numbers, but since they're the same number, switching them isn't going to work. So I'm going to try 4 and 1 now. Okay. So this is going to give me 3 when I multiply the outside, so 3 secant of x minus 4 secant of x, that will add up to the negative secant. So I've got the right factors, and now I just need to solve. So on the first one, I'm going to add the 4, then divide by the 3. So I'll get secant of x equals 4/3. And then on the second one, I would subtract 1. Okay, and again on this one, I don't have to worry about extraneous solutions because the only trig function I have in this equation is secant. Okay, so since I don't have two different trig functions, I don't have to worry about extraneous solutions if I get any quadrantal answers. Okay, so secant, this is going to be hypotenuse over adjacent. Okay, so this is not special right triangle, so I'm going to have to use my calculator to solve this one. Okay, so my hypotenuse is 4, my adjacent is 3. So to get this reference angle right here, okay, I'm going to have to do inverse, and I'm going to use cosine, okay, since there's no secant button, so I can look at the reference angle adjacent over hypotenuse. That cosine ratio is 3/4. So I'm going to go to my calculator, make sure that I'm in radians, and then I'm going to do inverse cosine of 3/4. And that will be one of my answers because I have an angle in the first quadrant. So the first answer that I'm going to get is x equals 0.723. Then in quadrant 4, you're going to do 2 pi minus your reference angle. So 2 pi minus that answer we just got. Remember, don't round anything until the very end. So don't type in the rounded numbers in your calculator. Either do second answer or arrow up to it and highlight it. If you type in the rounded number, it might mess up the last decimal or 2 of your answer. Okay, so these are going to be the two answers I get from this equation. Then this will be -1/1. So again, hypotenuse over adjacent. I know the hypotenuse can't ever be negative, so it's the adjacent that needs to be negative. Okay, and this one again is going to be a quadrantal one because the hypotenuse and the adjacent, they're both 1. Okay, which only happens for quadrantal solutions. And remember, adjacent goes with x. So I'm looking for where x is -1, which would be on the left side. Okay. So this angle right here is just going to be pi. So these will be the 3 solutions to this equation. Okay, and again, even though I got a quadrantal answer, I don't have to worry about it being extraneous because there's not 2 different trig functions in here. Okay, let's go ahead and go through another example. Okay, but this time we are in degrees. Okay, so solve each equation from 0 to 360 degrees. So again, this is one I'm going to have to factor because I have different trig functions. Okay. However, this isn't like the last one that was a trinomial where we had sine squared, then sine, then a constant. Here we have 2 different trig functions. So on the ones, if you have 3 terms, okay, and 2 of them are reciprocal function and 1 is a constant, what you're going to want to do is rewrite cosecant as 1/sine of theta plus 5. And then anytime you're solving an equation, if there's fractions, I would always get rid of the fraction. So I'm going to go through and multiply both sides by sine. Okay. So here it's going to cancel. It'll leave me with 1. And then I've got to do 5 times sine of theta. That'll be 5 sine of theta. And then 6 sine of theta times another sine of theta is going to be sine squared. Now this is a trinomial I can factor. Remember, to do trinomial factoring, it's got to be squared, then a constant term, then a linear one. So whatever the highest degree is, the middle degree has to be half of it, and they have to be the same trig function, and then your last term has to be a constant. So first I'm just going to rewrite it in degree order. And then I can go ahead and factor this one. So what multiplies to 6 sine squared? I'm going to try 3 sine of theta and 2 sine of theta. And then what multiplies to +1 is just going to be +1 and +1. That'll give me 3 plus 2 sine of theta. That'll add up to the 5. So again, I'm just going to set each of these equal to 0. So subtract 1, divide by 3. And then on the second one, I'm going to subtract 1, divide by 2. So this will be my opposite over hypotenuse. Okay, so this is not a special right triangle. So I'm going to have to use my calculator to solve this one. Okay, so my opposite is -1, my hypotenuse is 3. In order to get this reference angle, I'm going to do inverse sine. Sine is -1/3. And remember, when you're finding reference angles, you don't ever type in the negative. Okay. So to get the solutions to this first equation, I'm going to have to use my calculator. I'm going to switch over to degrees. And then to get my reference angle, I'm going to do inverse sine of 1/3. Okay. And that is going to make my reference angle 19.471 degrees. Okay. Then in quadrant 3, I'm going to do 180 plus that. In quadrant 4, I'll do 360 minus my reference angle. So I'm going to have 180 plus my reference angle, and then 360 minus my reference angle. So those will be the first two answers I get, 199.471, and then 340 degrees, 0.529 degrees, always 3 decimal places. Then on this second equation, this time, this is going to be special right triangles. I have a triangle that has a side of 1 and a hypotenuse of 2. That'll just make my adjacent side √3. So it's going to make my reference angle 30 degrees. Okay, so again, I'm going to do 180 plus and 360 minus the 30 degrees. And that is going to give me 2 more answers of 210. And then 360 minus is going to be 330 degrees. Okay. And again, I don't have to check for extraneous solutions on this one because nothing's quadrantal. Even though I have cosecant and sine, I have 2 different trig functions, I didn't get any quadrantal answers, so I don't have to worry about extraneous solutions. So let's go through one more example. So I've got 3 terms again, so it's going to be one that I have to factor. Okay. So before I do that, I'm going to set it equal to 0. Okay, so I'm going to subtract the 11, and I'm going to subtract this, but I'm going to go ahead and change this to 2 over cosine. Okay. And then I will multiply through by cosine to get rid of the fractions. So I'm going to have to distribute this cosine to all 3 terms. So this will be 6 cosine squared of theta minus 11 cosine of theta minus 2. Then I can go ahead and factor. I tried 3 cosine and 2 cosine first. It didn't work. So now I'm going to try 1 and 6. The 2 is going to have to go here. I couldn't put the 6 and the 2 together because there'd be a GCF. Then subtract 1, divide by 6. Over here, I'm going to add 2. So this is my adjacent over hypotenuse. So I'm going to have to use my calculator on this one. These 2 angles will be on the left. So to get this reference angle right here, I'm going to do inverse cosine of 1/6, my adjacent over opposite. That's going to give me a reference angle of about 80.406 degrees. Okay, then to get those 2 answers, I'm going to do 180 minus. That'll give me 99.594 degrees. And then 180 plus is going to give me 260.406. And then on this last one, I'll get no solution because